Okay, for the past couple of weeks, we've been working on famous problems and objections and critiques. And today I want to start with famous so-called scientific critiques. That's why I put scientific in quotation marks, scare quotes as they're called. There are a lot of them, and there's a lot to talk about, and I'm in no particular hurry. So if we can get what we discuss clear and understood, thank you, then that'll be fine. And if we don't cover all the questions that are out there, at least if we cover some of them thoroughly, it'll give you a feeling that some that sounded very, very convincing may have more or less than meets the eye. Well, let's start with the age of the universe. This is one that people do worry about. According to the official Jewish chronology, we are in 5780 something, and the scientific chronology is about 13.8 billion years, so there is a difference there. There's a discrepancy somewhat. The truth is that Maimonides, 900 years ago, faced a much worse problem, because in that times it was 4,000 something, and the official scientific opinion was that the age of the universe is infinity. There's no beginning at all. So that's a much bigger gap than just a mere 13.8 billion, which is a finite number. And Maimonides faced this problem in part 2, chapter 17 of the Guide of the Perplexed. And I will explain to you what he said, and then I'll show you how it applies to our circumstances, and then we can discuss it. Maimonides said, I want you to imagine a child, a boy who's born, and after several months, his mother dies, and his father moves to a colony of only men. And he grows up in this all-male colony. At a certain age, he asks his father, how did we come to be? How do we come to exist? We people, by which he means men. And his father tells him, well, there are others who are like us in many ways, but unlike in some ways. And we all start out as tiny miniatures inside the abdomen of one of them. We are in that position for 9 months. And then we come out and we grow to develop as you see us now. So the child asks his father, tell me, when we are miniatures inside the abdomen of those others, can we breathe? And the father says, no. Can we eat, drink? The father says, no. So the son says, I know that the story you're telling me is false. Everyone knows that a human being who doesn't breathe for 10 minutes is dead. A human being who doesn't drink for 3 weeks is dead. A human being who doesn't eat for 3 months is dead. You're telling me we're in there for 9 months without breathing, eating, and drinking? The story you're telling me is false. It cannot be true. Now let's see. From the point of view of the experience of that child, what he's saying is correct. In terms of his experience of the world, a human being existing without breathing, eating, and drinking is not going to survive. What he doesn't know is that there's an entirely different type of existence for human beings, which isn't dependent upon breathing, eating, and drinking. The uteral position of a fetus doesn't require those things, but he doesn't know that. So taking his world that he's observed as the norm for everything, extrapolating from what he sees to the whole of the creation, the whole of the universe, he's right in concluding that it's impossible. It's just that there happens to be something in the universe that doesn't fit his extrapolation. Okay. Now, our picture of the way the universe comes into existence is this. God creates the universe out of nothing, and there are 6 days of creation. During those 6 days, the world as we know it comes into existence. mass, energy, planets, life forms. Not only mass, energy, planets, and life forms, but the laws of nature also come into existence. During the 6 days, the laws of nature that we see aren't yet in existence. The creation process is not finished yet. What we see is the way the world has been functioning from the end of the 6 days on. Now, we look at our world, we look back as far as we can see, and we see certain types of laws operating, and we say, this is what we see, just like the boy in the colony of men says, this is what he sees. So we say, this is what we see, and then we generalize and say, this is all there is, this is all there ever was, this is all that ever has been. Everything follows from these laws. Just as he said, human life is only the way I see these men living in the colony. And just as he leaves out females and the state of being of a fetus, so the one who's looking at our world leaves out the 6 days of creation, which are utterly different because they don't obey the same laws. He just extrapolates to everything willy-nilly without any distinctions in kind. So that being the case, he's drawing his conclusion on the basis of the world that he sees and the laws that he observes. But that doesn't justify the conclusion that what he infers is true, because there can very well be another realm prior which doesn't fit the laws that he sees, doesn't operate in the same way. So that being the case, we with our picture are not refuted by the observations that he puts forward, because we explain his observations as the result of his limited perspective of observation, generalized, and we say that generalization leads to an incorrect conclusion. That's the way that the Rambam handles it, and we take his logic and use it. Let's talk about, there are objections to raise, let's talk about it up to here. Let's see if we understand each other the same way up to here. Yeah.
I don't know if you're going to go into this. So we were just at the big crater in the south, like this weekend, the Onward program. And
Yeah.
Yeah, and we talked about how it's kind of fun. We said that like the town is not so religious because they have a crater like next to them older than the start of time. My friend mentioned that there are some people that say that there is a correlation between the idea of like general relativity in the 6 days and the 12 billion year old start of the universe, and the expansion of the universe is also the expansion of time. So those 6 days divided up from like God's perspective was 6 days, but because of this expansion of the universe, now looking back at that time, it's 12 billion years.
Okay, I'm familiar with this type of reasoning, and I find it to be scientifically untenable. And the truth is that no scientists have signed on, no non-religious scientists have signed on and said, yes, our theories and our observations permit this kind of reasoning. So you don't have any external verification of it. I know the first set of reasoning in detail, and I can explain it to you, and I can explain to you what I think is wrong with it. There have been at least 17 variations on it. Later, I haven't bothered to follow all the variations, but it's the same kind of, I think the same kind of failure. Gravity slows down time. That's been demonstrated in the laboratory. They tell you if you put a clock next to a black hole, it slows down almost to stopping altogether. And then they tell you, well, let's just take the sum total of all matter in the universe and ask, what is its total gravity? And then ask how much it would slow down a clock. And you get roughly the figure that the sum total of matter in the universe would slow down the clock from 15 billion years to 5.5 days. So That's why there are two perspectives here. There's the perspective of the sum total of the universe, and this perspective of your little clock in your hand. And you have to, when you take into account the gravity of the whole universe, you see that it could come out to be 5.5 days, and therefore it's compatible. Just depends which point of view you take. Okay, and that sounds possibly reasonable. It is true that gravity slows down time in some sense, does slow down clocks. However, one thing Einstein taught us is that a concept is defined by the way it's measured. It isn't that time is something or other, and then clocks measure time, like you measure the table with a ruler. How long is the table? 1 foot, 2 feet, 3 feet, and there's the table and the ruler. No, time is what clocks do. Space is what rulers do. That's what time is. So the first question, and the person who put this argument forward knew this. He said so. First question you ask is, you're telling me that time slows down and time is affected and so forth and so on, then you must have a clock in mind. And you have to have some clock which is slowed down by the sum total of gravity of the universe. Where's that clock? Why isn't my watch slowed down? My watch is in the universe. It's affected by all the gravity in the universe. Why isn't it slowed down also? Answer, because it's in the middle. The gravity's all around it. Gravity all around it cancels out. There'd be no gravitational effect at the core of the Earth, just like you weigh nothing there. And so the effect on time will be zero. It's at the edge of the black hole where it happens. Not at the center of the black hole. We're in the center of the universe. So where is this clock which the sum total mass of the universe is going to slow down to 5.5 days? Where is it? So the author of this book gives two suggestions at two different places. One, he says, is at the edge of the universe. Well, according to contemporary relativity theory, the universe has no edge. Has no edge. Everything's in the middle. Doesn't that sound strange? That's why it's all mysterious.
Wait, is that the observable universe or the actual universe?
The actual universe. Actual universe has no edge. The observable universe, of course, has an edge. It's not a constant edge. It's constantly changing because more material is coming in from further away. Of course, it has an edge at any time. No, the actual universe has no edge. And if that sounds mysterious to you, the standard example is this. Imagine you live on the surface of a basketball. You're very small, very tiny. You live on the surface of a basketball, right? Your world is the surface of the basketball. Now, any barrier to where you go? You're going to go north, east, south, west? Just go. Nobody's going to stop you. Everywhere you are, everything's all around you, right? Everybody else is all around you. Wherever you are on the ball, everybody else on the ball is surrounding you. Every place feels like the center because there's no center. In a curved surface like that, there's no thing that's called the center. Everything is equally surrounded by everything else. Okay, we live in a three-dimensional world curved in the fourth dimension. That's what Einstein said, and therefore everything has nothing. There's no particular center. There's no boundary. Nothing will stop you. You keep going in a straight line. Nothing will stop you. It's just that after a while, you'll come back to where you started from in a straight line, because that's what straight is there. That's the vocabulary that they talk about. So, if you're talking about a clock, my watch on my wrist, it's in the middle, and if you're in the middle of all the gravity, then it's going to cancel out. If you tell me the edge of the universe doesn't have an edge. The other thought was, well, it's God's clock outside the universe. If it's outside the universe, then the gravity won't affect it at all. This is not science. This is not science. In the world, it won't be affected, and outside the world is not science. That's one reason why no scientist has signed on. There's not really a scientific explanation of how 13.8 billion is going to be a flip side of 5.5 days. And then it was 15 billion, and now it's 13.8, has to be adjusted a little bit. Yeah.
So in that idea that if you start at a certain point and then you just keep on going in a straight line, you'll get to the same point, wouldn't that mean it's like a sphere? Like,
It'd be like a sphere, yeah, but so what?
Not just like the universe, not only the world, but like the universe is also
Well, but the point is this. A straight line is the shortest distance. The question is how you measure short. One way you measure short is the one that takes the least energy to get there. So Einstein will tell you all light rays travel in straight lines in space-time, even though when they go past the sun they bend, but they don't bend in space-time. The sun creates energy, and because of the created energy, straight in space-time is with what we, looking only in space, call a curve. But everything goes straight. All light rays go straight. And the same is true with a light ray. If the universe is closed, it'll come all the way back with no barriers. It's finite, but no barriers. Nothing stops it. Nothing stands in the way. Doesn't crash into anything. There's just no more than a finite amount of space to go. Yeah.
I think I'm still confused now on how Rambam solves the contradiction. The time starts after the 6 days of creation?
No, time doesn't start afterwards, but the laws of nature, which dictate how time flows and what happens in that time, aren't the same. Let me fill it out. You're asking, and I think you're right to ask. There are a number of ways of doing this. Rav Schwab suggested the following way, which is, how shall I say, most comfortable for people who are addicted to a scientific picture. And that's not a zero gain. It's a certain gain. What about the history of all the things that we see? The crater that you talked about, development of life forms, the sequence of life forms. Notice I didn't say evolution. We'll talk about evolution in Hashem. But the sequence of life forms that we have in paleontology and all the rest. So one way to fit it all in with our picture is to say that the 6 days of creation are 6 24-hour periods, that our sources are agreed upon, but that things happen in those 6 days much faster. Much faster. Yes, the dinosaurs existed, but instead of for 60 million years, they existed for 6 seconds. They're always compressed in 6 seconds. And you say, but that's going to exceed the speed of light, and it's going to exceed the material's strength, and so forth and so on. Yeah, it certainly will. But those things are relevant only because of the laws that we have post the 6 days. I mean, Maimonides actually says these words. The laws of nature that we have in our world, that we observe post the 6 days, those laws are not what was going on during the first 6 days. Now, there's got to be something there to keep time. So we can talk about 6 24 hours, and the Rambam talks about that. What the thing is there that could be keeping time, but many, many other things weren't functioning the way they're functioning today. So you can fit it all in. The record of the events is right. It's just stretching it out to 13.8 billion years. That's dependent upon the laws that we see operating today, operating everywhere, universally, and that's not true. Turns out that that's not true. Yeah.
I had also heard that there's a possible explanation that, like, if you take into account that a day is 1,000 years in God's life, and that there was 6 worlds before this one, then you get to like the.
Yeah, right. Those words are poetry, and they're serious as poetry. But our sources take the 6 days and calculate the phases of the moon and the length of dates of Adam, who was created on the 6th day, and our tradition is not thousands of years old. So none of that affects the way in which our sources take these days. By the way, I should say this just as a piece of backup. Maybe I should have started with this. When you talk about reconciling science with religion, the question is, what do you mean by religion? Some people think religion means the first chapter of Genesis, full stop. There's a lot of flexibility there. A lot of flexibility there. That's not what we take the project to be. There could be 2 different projects, and people can work on 2 different projects. For us, it's the Jewish tradition, which means not only the first chapter of Genesis, but the whole 1,000 pages of the Tanakh, plus the commentators and official editions that came from our sages throughout the generations. So, yes, maybe you could say, because you're doing it with the English translation, in between tea time. So why can't a day be a longer period of time? Maybe an epoch. You could say that. But if you can't find any Jewish expositor who says it, then it's not going to be reconcilable with the Jewish tradition. It's reconcilable with some other new independent reading of the first chapter of Genesis, but that's not the project we think is a relevant project. Yeah.
I just want to make sure I understood what Rob said. So, is it that the scientific calculation of 13.8 billion years age of the universe is incorrect because we don't know how time worked during the 6 days? There's no way to really reconcile?
Yeah. Let me give you an example. I heard this from Zwicker Shalevsky many years ago. Imagine an ET visiting the Earth. And he first observes a 16-year-old. And he observes him for a year, and he plots how much does he grow in the year. How much does a 16-year-old grow in a year? 5% maybe? Maybe less? Okay, now he's told that he started out as a single cell, and I think the last calculation is he's now 35 trillion cells. How old do you think he is? Well, let's see, he grows 5% per year. Starts out as a single cell. It's 35 trillion cells. A lot of time. That's going to take a lot of time. Now, they grow and they multiply, but still, 35 trillion cells ought to take at least 1 billion years, right? It's got to be 1 billion years old. What's the answer? The answer is he doesn't always grow at the same speed. The first cell doubles in 20 minutes. Doubles! That's not 5%. That's not a year, right? And then you have 4, and you have 8, you have 16. Goes up like that. So because he doesn't know that the growth rate is different, he extrapolates and he gets a terrifically wrong answer. Once you realize that their conclusion is based on extrapolation, then you have to ask, what reasons are there to trust that the extrapolation is correct? Extrapolations often make terrible mistakes.
So the number's wrong altogether, likely.
That's right. That's right. Or at least, let me put it this way. Given that we have another point of view and we can explain what they see and yet deny their conclusion, they have not demonstrated that their conclusion is true. They would have to rule out our alternative picture. Yeah.
You mentioned there's no concept of measuring time without a measuring instrument, if I'm understanding the...
Well, without a clock.
Right.
I mean,
Clock being
cesium atoms, which vibrate, is also a way of measuring time.
Right. Well,
It's not an
that's
instrument,
measuring
but the word instrument means something a person creates for a purpose. You don't need an instrument. You need something that moves in a regular fashion.
Right, so with that in mind, God tells us that He created the world in 6 days, and our sources tell us what those 6 days represent. But if God is giving us a duration of time, what is the measurement device, so to speak, or the method of measuring time that God is using to tell us that He made the world in 6 days?
Well, the text talks about a variation between light and darkness. That's what the text talks about. So there's something that's creating light and varying in its operation. That's what the text says explicitly, right?
So the time is being measured, so to speak, by the variation of light?
That's right. This, whatever that variation of light is that the text is talking about, that's the physical effect that is counting the time, and then the things that happen in it is something else.
So that tracks the 6 days.
That's right. Okay, now some people say, listen, you've created a possibility, and we agree with you that it's possible. Why should a mere possibility weigh against positive evidence? I'll give you an example. Somebody's accused of a crime, and we have evidence. We have footprints and fingerprints and a motive, and a weapon, and somebody says, you know, all that could have been planted by the mafia. It could have. It could have. Will that defeat the case against him? Probably not. You have positive evidence. You don't have any reason to think the mafia did it. Citing it just a possibility of making a mistake doesn't deprive you of your conclusion. A whole chapter in my book is devoted to that subject. You don't fight with possibilities, you fight with probabilities. So aren't we just offering our alternative as a possibility and thereby resisting positive evidence? I think that objection is correct. I think it's correct. I answer it by saying we have independent evidence that our alternative is correct. We have independent evidence that the Jewish tradition is supported and is true. My whole book, Reason to Believe, is dedicated to that subject. So I do believe we would have to present some reason to think that the tradition is true, and then you have the positive observations and calculations of science. You have the evidence in favor of the tradition. They give you two different pictures, and then at the very least you say that you have to evaluate which one is a superior picture. Having said that, I want to repeat something I mentioned a moment ago, but I didn't stress. Let's suppose you have two competing theories, A and B. A has its evidence, and B has its evidence. Usually the conflict is symmetrical, so that when you look at it from the point of view of A, you say, well, okay, I believe in A, here's my evidence in favor, however, there's also B, and B has its evidence in favor, so B is uncomfortable for me. Because since the evidence for B is in favor of B, and B is against A, then the evidence for B is against me. So when I'm looking from the point of view of A, I have a mixed picture. I've got evidence in favor and evidence against. And then people looking from the point of view of B have the same situation. The evidence in favor of B counts in favor. The evidence in favor of A, which is incompatible with B, counts against them. So they're looking at a mixed picture where some evidence in favor and some evidence against. That's the usual situation. But it isn't always that way. It isn't always that way. Because sometimes, let's take from the point of view of A, okay, A is here, A has its evidence counting in favor. Now somebody says, well, what about B with its evidence in favor of B? And A says, I can explain that also. I can explain it. So it doesn't count against me. Wow. So A is not pressured by the evidence for B. That gives A leg up. If B can't do that, if B has to remain with a mixed picture, evidence in favor of B is good and evidence in favor of A is bad, then A is in a better position. Because B is suffering the opposition of the evidence from A. Whereas A isn't suffering that because A can explain away the evidence for B. Now, how does that apply to our case? Well, we can explain why the scientist sees what he sees. If somebody asked us, what do you do with all the scientific evidence? We don't say, well, it's against us and we have to live anyway and we believe it anyway in spite of it. We don't say that. We say the scientist is observing the world in terms of the laws that are post the 6 days, and he may have observed them correctly, his calculations may be correct, but he's not taking into account that there's another piece of history to which it doesn't apply. So I'm not embarrassed by the scientist's calculations. I can explain away the scientist's calculations. I claim that the scientific world cannot explain away the evidence that the Jewish tradition is true. So they are forced to take a mixed picture. They have their calculations and predictions on the scientific side, and then they have the evidence in favor of the tradition, which they can't explain. So they end up with a mixed picture, and we end up with a consistent picture. I think that's an element in our favor.
Can you give an example of one of those pieces of evidence for B?
I'll say it, but you really have to buy my book and read it in order to get it in detail, although there's a lot on the net. We have a record of an event at Sinai. That event has certain characteristics. Nowhere in the history of all mankind is there an event with those characteristics, that's a report of an event with those characteristics that is known to be false. Nowhere in the history of all mankind do you have a report like that that's known to be false. That means to me that the whole history of mankind is that this report must be true. That's the evidence from the totality of human history. Now, it takes 100 pages to work that out in detail. I told you I'd just be able to tell you but this I have on my website. It's called the Kuzari Principle. On my website I have a couple of expositions of it, and you can take a look at it there. That's one thing. I also argue in the book that the survival of the Jewish people has no remotely plausible natural explanation. And I also respond to the thought, well, it doesn't have one yet, but of course we'll find one tomorrow because science is going to solve all problems. I deal with that in detail. If you know something about the history of science, philosophy of science, you see that that's a very weak reply. So I think that the survival of the Jewish people is positive evidence that something more than the naturalist position is going on. So those are two large pieces of evidence that I discussed there. There are more, but they're successful predictions, which are against all probability. I have that in there also. I don't think the scientific world can explain it. I have had lots of correspondence on this. I have a number of pieces on the web, especially in my blog and also on my website, where I deal with some of the criticisms in detail. So if you're interested in looking at what we call the shaklatari, the back and forth, I've taken the responsibility to answer those objections, many of them. Yeah.
It seems like you're saying that scientists are trying to impose basically what they see, this reality, on a reality in which the rules that we observe now had not even come into creation.
That's right. By the way, I think it was Professor Bohm who said that projection, from a completely scientific point of view, he said that projections to the early universe run against the problem that the laws of nature have been changing over time also, and you're projecting back with the laws you see today. And therefore projections to the early universe may be unfounded. So it's not an impossible idea even in scientific terms. Even in scientific terms. Okay, that's the age of the universe. Now, let me follow up with the kind of objection that people raise. This is a more philosophical objection. I hope I'll be able to finish this today, and then tomorrow I'll go on to something else. People say, listen, you're talking about a picture that's not naturalistic. Surely the naturalistic picture of the world is the right picture. Surely it's the most logical picture. Surely it's the best attested picture. Isn't all of science based on an assumption that the world is naturalistic? Isn't science the way to find out the truth about the world? Aren't you fighting with you're shooting peanuts at a tank? There's no comparability between what the naturalistic approach has taken in explaining the world to what you're using. I have two things to say here. There are two different ways in which science can be based on the assumption of naturalism. One, I think, is neutral and perfectly acceptable. Different people do different things. Some people play musical instruments, and some people are economists, and some people are dietitians. The world needs different people doing different things to create a rich and successful culture. If a scientist says, I work with naturalism as an assumption, I look for naturalistic explanations for things, that's what I do. I'm good at it, and we're successful at it. I think it's a worthwhile project. You have a different project? No prejudice. No prejudice. Somebody said, let 100 flowers bloom. We don't particularly prize his opinion, but look it up in Google, you find out who said it. So that way, science wouldn't be prejudiced against non-natural explanations. It's just they're not doing that. They're doing natural explanations. That's perfectly okay. If science says, we believe that what we're doing is all there is. There isn't anything else. There can't be anything else. Naturalism is the nature of the universe, period, with no possibility of any exception. And therefore, our method of investigating the world is the only valid method of investigating the world. And if you claim there's something that goes beyond that method, we know it's wrong. That's imperialistic naturalism. Or naturalism claims that it is the correct picture of the sum totality of the world. Well, I think there's absolutely no reason to cave into that. Absolutely no reason to think that. Aren't there unsolved problems in science? There are loads of them. Tell me that scientific progress is conquering them one by one? Yeah, it certainly is. And scientific progress is also inventing new problems as it goes along. Not only that, but scientific progress is undoing old solutions as it's going along. It's not a one-way track up. It's some gains and some losses. If the world has no beginning, there's nothing to explain about why it's here. It's always been here. Since the Big Bang, that comfortable satisfaction has been removed because it has a beginning. So something which people thought was understood, clear, simple, and obvious becomes now very problematic. That's progress. It became problematic. The cell was supposed to be a little vesicle holding liquids. It now has thousands of miniature machines operating at lightning speed, and no one can explain where they came from. From being something absolutely simple, not needing an explanation, it now becomes so far inexplicable. Science also destroys what you thought was understanding before. So talk about progress. Progress is a two-edged sword. Not obvious that it's going up in every direction. That's one problem. A worse problem philosophically is this. So you're a naturalist. You believe that the universe is all and only natural. Could you give me some information about what you mean by natural? What kinds of things are natural things? What kinds of things are ruled out? Suppose I ask you now, in 2023, what will you do? Take out the science textbooks of 2023 and read them to me? That's what you hold the universe is, must be, without change, without variation, and without anything missing? Wouldn't you then lock science into today's view without any possibility to discover something new? Without any possibility of discovering something was false? You surely don't want to say philosophically that the world is what 2023 says it is. Surely that's not a right attitude. Suppose 500 years ago they had done that. We'd be back with Aristotle. We wouldn't have allowed Newton. We wouldn't have allowed Copernicus. We wouldn't have allowed Laplace. We wouldn't have allowed any of it because it's not natural, because nature means what Aristotle said. So surely by natural you don't mean the current picture. So you don't mean the current picture. Then what do you mean exactly? When you say it's natural, want to rule out our picture because it's not natural, what do you mean exactly? So some say, well, we mean the picture that will be arrived at when we finally understand everything. Really? You really are an optimist, aren't you? You're sure we will finally understand everything? Really? Why are you sure of that? Couldn't it be that some things will escape our understanding forever? Number one. And number two, what kind of changes do you anticipate between now and then? Wasn't it enough that the Earth as the center of the universe turned out to be wrong? Wasn't it enough that things move in circular orbits turn out to be wrong, they're elliptical? Wasn't it enough that in addition to objects there are also forces and energy, which are different categories of existence? Wasn't it enough that space and time don't exist? There's only space-time with relativity, and the clocks depend upon how fast you're moving? Wasn't it enough the quantum mechanics, where a thing has a property which you measure, and if you don't measure it doesn't have the property? It's replaced by a probability wave? Isn't that enough? Well, what kind of changes can you predict in the future or rule out in the future? You can't rule out any, and you can't predict any. You don't know where it's going. Well, if you don't know where it's going, then you don't know what the final picture will look like. If you don't know what the final picture will look like, how can you say the final picture will rule your picture out? You don't know. So naturalism suffers two great disabilities. To think of it as the be-all and end-all of the entirety of the world. And that's just philosophical fluff, and you don't trust that. And I wouldn't be terribly upset if you didn't trust philosophy. Let me point out something very specific, very precise. You all know very well that everyone believes in and trusts a non-naturalistic discipline. If naturalistic means the method of science, observation, theorizing, experiment, and so forth and so on, measuring, doing and calculating, if that's what it is, then math is ruled out. Math isn't done that way. No observations, no theories, no predictions, no experiments. There's just proof. What's that? Well, it's not physics, not like physics at all. Truth is, my field was philosophy and mathematics. Nobody understands how mathematics works. But one thing's for sure, it isn't done the way physics is done, and everybody trusts it. So it can't be that the method of physics is the method of knowledge, the method of understanding, the method of fact. Can't be. Then who says there aren't other ones? The whole position is based on a network, made of noodles. So it has no solidity whatsoever. So don't let anybody push you into a corner and say naturalism is the name of science. If they mean that that's what they do and leave open the possibility that there are other things to be done, fine. That's fine. A real liberal attitude. But if it's a imperialistic attitude, this way and this way only, not to mention, by the way, that there's a gigantic literature about the method of science and people don't agree what it is. To articulate what it is and say what it is, I'll give you one example that I heard from a philosopher whose philosophy I don't respect, Richard Rorty, who's very popular. I heard him say it at a national convention. He said the following: every theory in science that has ever been accepted has been accepted at a time where there were known counterexamples. Never has there been a theory that without known problems, known counterexamples. So when you accept a new theory, what you're doing is taking the old theory with its counterexamples and looking at the new theory with its counterexamples, saying, this one's better than that one. How do we do that? Nobody knows. Nobody knows how that judgment is made. Here's the Lego version of science that he's pointing out is wrong. The Lego version of science is this. Something happens. Gee, why did that happen? I wonder why it happened. Let's think about it. I bet if air is made out of atoms, then it would happen that way. Okay, you bet. You thought it up. That's nice. Test it. Test it to see whether it works. Let's see, if air is made out of molecules, then when I compress air, it ought to create heat. Oh, I could try that. I'll take a container with a plunger and then push the plunger down and see if it gets hotter. And lo and behold, it gets hotter. Look at that. It passed the test. Okay, keep it. It passed the test. That's good. Try another test. Try another test. As long as the theory passed the test, keep the theory. Fails the test, that means it's wrong. If it's wrong, junk it and look for a new theory. That's incorrect. That's not how science works. Because no theory has ever been proposed that didn't have known counterexamples. When quantum mechanics was proposed, and they calculated the energy of the electron, you can look this up, right? The calculation showed that the electron has infinite energy. Each electron has infinite energy. That's not correct, is it? No, they knew there was a problem, but the attitude was, okay, you're right, it's a problem. We'll solve it. 20 years later, they came up with a mathematical trick called renormalization. You can look it up. Where at a certain point in the calculation, you subtract infinity. Then we subtract infinity, it doesn't go to infinity. Why are you subtracting the infinity? Because it gets rid of the infinity, see, and then we get the right answer. So we just subtract it to make it work. Good. That gives you real deep understanding. It makes you confident that we're on the right track, right? Okay, the last 20 years, people have thought up possible explanations why renormalization works. But for 30 years, it was accepted without knowing why it works. And the theory wasn't junked before renormalization. You don't throw out a theory because there are problems that can't be solved. That's not a reason to throw out a theory by itself. And what the reason is and when you make the judgment is very difficult to say. I told you about Uranus and Mercury, or have I not told you to this group? Okay, this is a story of a triumph and a terrible failure. Newton's laws predict how the heavenly bodies move. The planet Uranus wasn't moving right. It wasn't moving right. And there were two thoughts. Maybe Newton's laws don't always work. They work sometimes in some places, but not everywhere. That was one thought. Other people, more conservative, said, no. Newton's right. Newton's universal. There's something out there that we don't see that's disturbing the way Uranus works. There's another heavenly body out there that's distorting what's happening to Uranus with its gravitational pull. We haven't found it yet. Okay, two possibilities. The second group made a calculation. If it's in this position and with this amount of mass, this is what could do it. And they said to the astronomers, point your telescopes in that direction at that time and take a look. Now, there are billions of cubic miles of space out there. You're going to tell them where to look exactly? They told them where to look exactly, and they found Neptune. That's astonishing. That's an astonishing success. Newton was right. The laws are all correct. There's another thing out there disturbing how Uranus moves. Fine, that's a success story. Well, Mercury doesn't move right either. Mercury doesn't move right. According to Newton's predictions, it's not moving correctly. So they thought, maybe the same problem is happening with Mercury. Maybe there's some other little planet over there that's very dense, and we haven't found it yet. So they were searching and searching, and they hadn't been able to find it. Then came Einstein. Einstein concocted his theory of relativity, and he calculated Mercury. Guess what? It fits exactly, because the laws are entirely different. The whole picture was wrong. So with Uranus, they got a conservative solution, and with Mercury, it was only the radical solution that helped. How do you know which is which? You don't know which is which. You don't know how serious an objection is and what you should do with respect to the objection. It's one of those things. It's one of those judgment things, and sometimes scientists are divided as to what judgment would tell them to do. So when you talk about the method of science, it isn't as simple as the Lego version would tell you. And it's very controversial, and there isn't a lot of agreement as to how to describe what the method of science is. So to elevate the method of physics as the method of all knowledge and the method of all reality is just without any foundation whatsoever. So that kind of objection isn't going to work. Okay, tomorrow I'll start with a review, and we'll see whether questions came up in the 23 hours in between, or maybe you Googled things and found some things that were wrong with what I said, which is fine with me, and then we'll carry on from there.